Last month, I looked at the NHL and I calculated the absurdly low probability of no Canadian team winning a Stanley Cup in the last 32 years. Doing this made me think of several other droughts in professional sports. You could look at cities like Buffalo, Phoenix, or Cleveland and calculate the probability of the droughts that some of their teams faced. However, one recent championship drought has received a lot of attention in the past few years. No team representing New York City has won a championship since the New York Giants did on February 5th, 2012. 2012 may not seem like a long time ago, especially compared to some championship droughts that predate social media, a unified Germany, or widely available colored television. However, when you consider how many teams there are in New York, it's actually quite large. Between all of the big four sports leagues, the MLB, the NBA, the NFL, and the NHL, there have been over 100 seasons completed by New York teams, but 0 championships in that time period. In the Canadian Cup drought video, I talked about more than 200 seasons of hockey played without a championship, so this New York drought may seem like rookie numbers in comparison. However, the thing that makes New York's drought really jarring is that this is New York City, one of the most glamorous places on the entire planet. Understandably, teams like the Ottawa Senators and Winnipeg Jets may have a competitive disadvantage, but such a disadvantage shouldn't exist in New York City, where many of the most rich and iconic franchises of their respective leagues reside. In this video, we're going to look at historical betting lines to analyze the New York City Championship drought. By the end of this video, I hope to answer the following 5 questions. How likely was this championship drought to happen in the first place? When did this championship drought officially become improbable? What teams were the most likely to end this championship drought? In what years did New York have the best chance to end this championship drought? And finally, how many championships should New York City have won during this time period? Before crunching all of these numbers, I will quickly describe how I calculated them. All of our calculations today will depend on something known as probability. The probability of an event is the likelihood that that event will occur. Probabilities are written as decimal values from 0, a 0% chance, all the way up to 1, and a 100% chance, a guarantee that something will happen. To convert from a percent chance to a probability, just move the decimal 2 places to the right. Now, we are going to estimate the championship probability for each New York team in every year during the championship drought. How we're going to do this is based on the team's betting odds for winning a championship going into the season. On the site sportoddshistory.com, we can look at the betting lines for every MLB, NBA, NFL, and NHL season in the past 15 years, and we can see the betting lines for the New York teams to win the championship going into each season. There's no definitive, perfect way to measure how likely a team is to win a championship, but this is likely the best public data we can use for our model. The way these odds are listed is by using American odds. American odds are listed as minus some number if that team is favored to have a certain outcome, or plus some number if the team is an underdog for that outcome. If the odds are in the form of plus some number, then the lower that number is, the more likely the bookies think that that outcome will occur, and the lower the profit will be if the bet is successful. Now, from these odds, we can convert to something known as an implied probability. If the American odds are in the form of plus some number, we can get their implied probability by taking 100 and dividing it by 100 plus that number. If the odds are in the form of minus some number, we can get the team's implied probability by taking that number divided by 100 plus that number. During this experiment, almost all of the championship odds that I found were in the form of plus some number, since it's extremely rare that a team will be favored to win the championship at the start of a season. It's just inherently unlikely. In the 100-plus seasons that we are going to be looking at today, the NBA's Golden State Warriors, at the peak of their dynasty, were the only teams to be favored to win the championship at the start of a season. I'm going to demonstrate how to obtain implied probability using the 2012 MLB season as an example. So let's look at our New York teams here. Going into the season, the New York Yankees had American odds of plus 600 to win the World Series. To convert these odds to an implied probability, we take 100 divided by 100 plus 600, which equals 100 over 700, or 1 over 7 if we reduce that fraction. In decimal form, this equals approximately 0.142857, corresponding to roughly a 14.3% chance to win the championship. Not bad. Note that in this video, I will be rounding all of my calculations to 6 decimal places. The New York Mets, on the other hand, had American odds of plus 8,000 to win the World Series. To convert these odds to an implied probability, we take 100 divided by 100 plus 8,000, which equals 100 over 8,100, or if we reduce that fraction, that's a 1 in 81 chance. In decimal form, this equals approximately 0.012346, corresponding to around a 1.2% chance of winning the World Series. Now, there's one little adjustment we have to make before we can put these probabilities in the spreadsheet. Let's quickly look at the probabilities of every other team in the 2012 MLB season and add them up together. When we have events like this that can't happen simultaneously because two teams can't win the World Series in a given year, we can get their combined probability by adding them together. Events like this are known as disjoint events. In Google Sheets or Excel, it's really easy to find the combined probability using the sum command. So, if we look at our little sheet here are the championship probabilities of every single MLB team, and here is the sum of all of their probabilities. Do we see an issue here? Look at the combined probability. It's around 1.34. Probabilities cannot be greater than 1. It's impossible for something to be more than a guarantee to happen. The sum of all of these probabilities should be 1, because there should be a guarantee that one of the MLB teams will win the World Series in a given season. The reason the combined probability is 1.34 here, and not 1, is because of something known as the overround. The overround gives odds makers more legroom and more ability to profit. Odds makers aren't creating betting lines for the love of the game. They want to take all of your money in possessions. I talked about this idea more in my video about the Canadian Stanley Cup drought, if you're interested. Now, we know that the overround exists, but what can we do about it? What we can do is use equivalent fractions to make something known as, maybe not known as much as just made up by me, as an overround adjusted probability. All we have to do is take that fraction of every team's probability over the sum of all the implied probabilities, and see what the equivalent fraction is when the denominator is 1. The numerator of this equivalent fraction will be our overround adjusted probability, and this is what we are going to use in future calculations. So, for the New York Yankees, the implied probability over the sum of all probabilities in the 2012 MLB season was 0.142857 over 1.336437. To go from 1.336437 to 1, all we have to do is divide 1.336437 by itself. Then, whatever we do to the denominator of the fraction, we must also do to the numerator of the fraction. So the numerator of this new fraction in our overround adjusted probability will be 0.142857 divided by 1.336437, which equals 0.106894. So, the 2012 MLB championship probability for the New York Yankees that we will use in our future calculations was 0.106894. With the Mets, we can do something similar. Their implied championship probability was 0.012346, so we can just take 0.012346 divided by 1.336437 to find our overround adjusted probability, and if we crunch those numbers, that's just going to equal 0.009238. So, our next step is to do this calculation across every season played by a New York team in all 4 sports leagues since the start of this championship drought. And if we put all of these probabilities in a spreadsheet, it would look like this. In this document, we now have the probability of any of the New York teams winning any of the championships awarded after February 5th, 2012. The year column corresponds to the year the championship was actually awarded in, not the year of the season. This distinction only really matters for the NFL, where the official year of the season is different from the year in which the Super Bowl is actually awarded. Before continuing, I will quickly explain why 5 entries here are 0. The New York Giants and New York Jets have a probability of 0 in the 2012 column because we are evaluating the probability of no championships since February 5th, 2012. No NFL championship was awarded for the rest of 2012, so they had no chance of ending the championship drought in 2012. The Brooklyn Nets had a probability of 0 in 2012 as well, because they were still the New Jersey Nets and not the Brooklyn Nets. And finally, the 2025 Mets and Yankees are listed at probability 0 because the 2025 World Series hasn't been awarded at the time this video is being made. I could wait a few months, but then I'm at risk of having to throw this entire script in the trash. Now, we want to calculate the probability of no New York team winning any of these years. The formula that we're going to use to calculate the probability of no New York sports team winning a championship since February 5th, 2012 is the following. The probability of no New York team winning an MLB championship since 2012 times the probability of no New York team winning an NBA championship since 2012 times the probability of no New York team winning an NFL championship since 2012 times the probability of no New York team winning an NHL championship since 2012. All of these events are known as independent events, events where the occurrence of one event doesn't impact the probability of the other event happening. A New York team winning the Super Bowl is not going to impact the probability of a New York team winning the Stanley Cup, for example. And when we have independent events like this, we can get the probability of all of these events happening, in this case, none of these teams winning a championship in any of their leagues, just by multiplying their probabilities together. So that equation that we just made will give us the probability of no New York team across any of the sports teams winning a championship since 2012. At this point, our next step is to determine those 4 probabilities that we're going to multiply together. We will have to determine the probability of no New York team winning a World Series since 2012, the probability of no New York team winning an NBA championship since 2012, the probability of no New York team winning a Super Bowl since 2012, and the probability of no New York team winning a Stanley Cup since 2012. And to determine all 4 of these probabilities, we have to do the following. The probability of no championship in 2012 times the probability of no championship in 2013 times the probability of no championship in 2014, all the way up to 2025. We are going to do this for every single league we talked about earlier. All of these probabilities are also independent, so we just need to multiply them together. So, if we can find these probabilities, we will then be able to find the grand total that we've been looking for. Now, the reason that we've divided these probabilities by league, rather than by team, is that it's very easy to find the combined championship probability of two teams in a given year. We talked about disjoint events earlier in this video, and two teams in the same league winning a championship in the same year are disjoint events. It is impossible for those two things to happen at the same time. So, to get the combined probability of two disjoint events, we just have to add them together. So, we will add the probabilities of teams in the same league. The Yankees and Mets, the Nets and Knicks, the Jets and Giants, and the Islanders and Rangers. So, instead of looking at each individual team, we can actually just look at the probability of either New York team winning a championship in each league. And then, if we combine the probabilities of New York teams in the same league, this is what our data looks like. So, now, for each week and each season, we have the probability of one of the New York teams winning the championship. However, we wanted the calculation of neither New York team winning the championship. So, to get this probability, we just use something known as the complement rule. The complement rule states that the probability of an event not happening is just 1 minus the probability of that event happening. So, for example, the probability of no New York team winning the 2014 NBA championship would just be 1 minus the combined championship probability of the Knicks and Nets in that year. So, if we make those calculations and put it in our spreadsheet, it then looks like this. So all we have to do at this point is take the product of no championships in each week from 2012 to 2025, and if we do that for each week, then we will have the 4 probabilities that we wanted to plug into our original equation. At this point, we have everything we need to break down each season, and how the probability of this championship drought changed year by year. And in this table, we have all of that information, and in the bottom right there, that is our magic number. So, the probability of no New York team winning a championship since February 5th, 2012 is 0.013549, or approximately a 1.4% chance. Conversely, this means that there was about a 98.6% chance of at least one championship being awarded to a New York team in the past 13 years. This isn't quite as ridiculous as the probability of the Canadian Stanley Cup drought, but it is still quite low. There's still some other interesting stuff we can do with our information here. We can also find the probability of no New York championships in a specific season by taking the probability of no MLB championship that year, times the probability of no NBA championship that year, times the probability of no NFL championship that year, times the probability of no NHL championship that year. Then, if we take the complement of this product, that'll be the probability of at least one New York team winning a championship in that year. If we break down the probabilities year by year, you'll see that 2013 and 2022 were easily the most likely years for a championship, with a probability of around 0.42 for both, so around a 42% chance. 2015, on the other hand, was the lowest, at around 0.15. Another cool thing that we can do is look at the 4 probabilities that we plugged into our formula earlier to see which league was the most likely to yield a championship during this drought. What we can do is take the probability of no MLB, NBA, NFL, or NHL New York team winning a championship since 2012, and then take the complement to get the probability of at least one MLB, NBA, NFL, or NHL championship during this time period. So if we look at the different leagues here, the MLB teams were by far the likeliest to win a championship, and their probability of at least winning one World Series was around 0.82. As someone who knows virtually nothing about baseball, this would have been my guess, given that the Yankees are an absurdly rich franchise. The NBA was next. Their probability of at least one championship was around 0.7. The NHL had a probability of around 0.6, and the NFL had the worst odds by a mile, with a championship probability of around 0.37. Part of this is the fact that the Giants and Jets have played one less season in this time frame, because we didn't include the 2012 season, but when you whiff 5,000 times on the coach and quarterback position, the bookies aren't going to respect you very much. We had the combined championship probabilities of teams in the same league, but we can also look at the championship probability from 2012 to 2025 for all 8 individual teams. To do this, we just have to take each team and calculate their probability of no championship in 2012 times the probability of no championship in 2013, all the way up to 2025. These probabilities will just be determined by taking 1 minus the championship probability of that specific New York team. It's like what we did with the combined probabilities, except we're not combining them. This will just give us the probability of that team winning no championship since 2012. So we just take the complement of this product to get the probability of at least one championship since 2012. If we look at the individual teams, the Yankees, Nets, Rangers, and Mets have had the best chances to win a championship, while the Knicks, Islanders, Giants, and Jets lag far behind. This graph shows how the probability of the championship drought changed as each year passed. To find the probability of the championship drought lasting from 2012 to a specific year, all you do is take the product of the probabilities of no championship in every year from 2012 up to whatever year you'd want to analyze. By the end of 2013, the championship drought was already improbable, and it only got worse and worse. One final thing we're going to look at here is the expected number of championships that New York should have won in this time period. It's clear that they probably should have gotten at least one, but should they have gotten more? The way we can determine this is by calculating the expected championships of the New York teams. The expected value of something is the sum of every outcome multiplied by the probability of that outcome happening. So if we look at the New York teams in each league, their expected number of championships in a given year would just be 0 times the probability of no championship, plus 1 times the championship probability. 0 times anything is 0, so the expected number of championships for the New York teams in the same league will just be equal to the championship probability that year. So, to find the expected number of championships since 2012, we just have to add them all up. So that means that the expected number of championships during this drought for the New York teams in the same league will just be all of the championship probabilities for each year added together. Then, to find the expected number of championships across all leagues, we just have to add the expected championships from 2012 to now for each league. If we do that, we get a total of 4.014 expected championships. So the New York teams probably should have won around 4 championships, not just 1. So there we have it. We have successfully answered every question that we wanted to answer at the beginning of this video. I was hoping that the number would be a bit more eye-popping, but apparently not. I wonder if there's any other sports droughts we can look at.